Suppose that 3 years ago I loaned $2,500 to John. The principal with interest calculated at 8% compounded semi-annually was negotiated to be repaid 4 years from the starting date of the loan. 18 months ago, John borrowed another $1,500 for 2.5 years, and that money had a 7% compounded semi-annually rate applied to it. John is now proposing to settle both debts with 2 equal-sized payments to be made 1 and 3 years from today. What should the payments be if money now earns 6% compounded quarterly? So let's set up a time diagram to deal with this problem. And this time diagram is going to get a little spicy because we do have 3 payment streams, all with varying rates. So we do have to be a little bit careful about how we draw this time diagram. Let's start with the initial loan that happened 3 years ago. The amount here was $2,500. And let's suppose that this loan is fixed. It's going to be repaid 4 years from the start date at 8% semi-annual. That means that the final payment should happen 1 year from today. I'm going to write this in as the first step that we have to deal with. We are going to have to calculate this future value, keeping in mind that 8% compounded interest rate. However, John wasn't done there, was he? He decided he needed a little bit more money 18 months ago. That's at the 1.5 year mark. So he went back and he grabbed $1,500. This particular loan was negotiated for 2.5 years at a 7% semi-annual rate. Luckily, 2.5 years from the beginning of that loan does land us at the 1 year mark. So we are going to have to calculate the future value of this money at the 1 year mark at that 7% compounded rate. And then finally, we have the renegotiation that's happening. So we have 2 equal-sized payments. We want to make an equal-sized payment 1 year from today, and an equal-sized payment 3 years from today. We're going to represent both of them using the variable x. So looking at how everything is shaping up, it seems reasonable for us to take the 1 year mark as the focal point. And that's going to give us basically a 4-step process. We're going to calculate the future value of the 2 initial borrows that we had. That's steps 1 and 2. Calculate the principal amount or present value of this equal-sized payment happening at the 3 year mark. And then we should be able to come through and compare our money, right? We want to add up steps 1 and 2. That's how much he owes in 1 year. And we want to be able to compare that to x plus 3. So we just have to be mindful of our changing interest rates here. Let's begin with our step number 1, which is finding the future value of the $2,500 loan. This has an 8% compounded semi-annual rate, so 0.08 over 2 here for I. And then we need to figure out how many compound periods this goes through. Well, the money's going through 4 years, and if the frequency number is semi-annual, or 2, that means we should be going through 8 compound periods altogether. This gives a future value of that particular amount of money as $3,421.42. In step 2, we'll take a look at that $1,500. It had a rate of 7% compounded semi-annually. So here we'll take 0.07 over 2 for I. This is going to go through 2.5 years of compounding. We need to multiply that by 2 because our frequency number is semi-annual, or 2. And that should give us 5 compounding periods altogether. This gives a future value of $1,781.53. Our next step is going to be to deal with that equal-sized payment that happens 3 years from today. In this case, we need to use the principal amount or present value formula. So we're going to take x to be the numerator of our fraction. And now we are negotiating this at a rate of, 6% quarterly, so 0.06 over 4. We need to pull this back or discount it by 2 years. So t is equal to 2, If we're going to multiply that by 4 because we have quarterly compounds, that means we should be going through 8 compound periods altogether. So I'm just going to leave that decimal number in the denominator for now, and we'll deal with simplifying it in our last step here. So now we should be in good shape to compare our payment streams. We know that we need to take the values we obtained from 1 and 2, and this should have the same fair market value as an equal size payment plus the principal amount that we calculated in step number 3. Adding up steps number 1 and number 2 give 5,202.95. So our next step is going to be to simplify the right-hand side. I've just inputted our principal amount here that we calculated in part 3. To simplify the right, I'm going to take the coefficient in front of our first x, which is the number 1, and I'm going to add to that 1 divided by that decimal number of about 1.12. And if we do that correctly, we should get a decimal number of about 1.88. And that's going to be our new coefficient for x. So in order to finish off this question and get x by itself, or isolate for x, we should divide both sides by this decimal number. Doing that gives about $2,756.22. So if we go back to our payment streams up top, what does that mean in conclusion? Well, it means we should be looking for 2 equal-sized payments. One of those equal-sized payments happens at the 1-year mark from today. One of those equal-sized payments happens at the 3-year mark. But when we combine those equal-sized payments, they have the same fair market value as the 2 previous loans that we took out. And those equal-sized payments are $2,756.22.